Welcome. In this one I'm going to show you how to find an expression to simplify the following here, the square root of ai. Now in this context, let's be clear. The a that you see is a number, for example, like 2 or 5, but the I is the imaginary unit. What we want to do is simplify this expression somehow as much as possible. So I'm going to proceed as follows. First, I'm just going to rewrite this by distributing the square root symbol to the a and I individually. So we'll have a and then I. Now again, because a is a number like 5 or 10, that part you can pretty much just leave. But then we have to handle the square root of I. So we want something that represents the square root of I. So I'm going to proceed as follows. On the side, that's a lot of work, so I'm going to say I raised to the 1/2. And then after that, I want to make this look perhaps like a more conventional complex number. So for that reason, I'm going to put here 0 plus 1i, and the quantity is raised to the 1/2. Why am I doing this? Because this is essentially the x part of a complex number, and the 1 here is like the y part of a complex number. So take a look now at the concept of a unit circle here, which is that, for example, since this is like 0 and this is 1, then on a unit circle, when you rotate to here, that's a pi over 2 turn. The point has the coordinates 0, 1. So that basically is your x and this is your y. 0, 1 here corresponds to 0 with the 1 here. And that's a turn of pi over 2 on a unit circle. So what I can do is I can rewrite this in exponential form as follows. Also, don't forget that from here to here, this is a length of 1. So I'm going to take that number 0, 1i. I'm going to write it in exponential form as a complex quantity. So it looks like a 1 from here. That 1 is like the length of the number. And then e raised to the I. And then here it's going to be pi over 2. Don't forget that all of this is still raised to this 1/2 on the outside of the parentheses. So the whole thing is then you're going to have to be hit with the 1/2 from the outside here, okay? So that operates on the exponent parts only, essentially. So when I do that, it's going to give me now 1, e raised to the I, and then pi over 4. But I can find that value pretty easily. You know why? Because it's pi over 4. We can read that from the unit circle. So let me erase this part and this part so it doesn't get in the way. Let's draw another unit circle for reference. So here, pi over 4 is a quarter of a turn this way. This is pi over 4 as an angle, say in radian mode. At that point right here, the value is as follows. For the x coordinate at this point, it's the root of 2 over 2, and the y coordinate at that point is also the root of 2 over 2. Why do we want to see those? Because then I can take 1 times e to the I pi over 4 and translate into these values here pretty easily. So it's going to be 1. Let me fix that. So it's going to be 1, and then here e will be rewritten as the root of 2 over 2, because that is the cosine of pi over 4. So let me not skip that step. So in other words, this is what I'm doing. I'm taking 1, and then I'm writing this as cosine of pi over 4 plus I sine of pi over 4. And then each piece can be replaced, so it becomes 1 times the root of 2 over 2 plus the sine of pi over 4 is also the root of 2 over 2 with the I. And the only thing then left is to take this and multiply back by the square root of a that we had initially anyway. So this will become now the square root of a multiplying this whole thing here. So the root of 2 over 2 plus the root of 2 over 2 with the I. And then this is a form of what we were looking for. That's it for this one. I hope you've learned something. Please leave a like and subscribe, and I'll see you in another video.